Hello everyone, I'm Sudha Udaya. Welcome to today's unit in the Building and Construction program. Before we begin, I want to remind you of the purpose of this program. Each unit is designed to give you the knowledge, skills, and industry behaviours required to become a competent and confident building practitioner in Australia. Throughout this course, I'll be drawing on more than 30 years of hands-on experience in residential and commercial construction. My goal is to connect the theory directly to real project situations, showing you how the National Construction Code, Victorian regulations, WHS requirements, and industry standards apply on actual work sites. As we move through each topic, think about how these principles translate into the decisions builders and site managers make every day. By the end of each unit, you should feel more prepared to apply these concepts in practical, safe, and compliant ways on the job. Let's get started. This presentation covers CPCCBC4021, Minimize Waste in the Building and Construction Industry. The focus is on practical planning, procurement, and site processes that reduce waste, improve recycling and reuse, and support safe, compliant disposal. We will follow the three elements of the unit: planning a waste management strategy, managing procurement to minimize waste, and managing the building process to reduce waste. This unit is about reducing waste across the whole project lifecycle, before materials arrive on site, while work is underway, and during demolition, excavation and clean-up. It includes understanding environmental requirements using standards and guidelines, selecting better materials and suppliers, and implementing workplace procedures that support waste separation, recovery, and safe disposal. The goal is less landfill, lower cost, and better environmental outcomes. By the end of this presentation, you should be able to plan a waste management strategy, manage materials procurement to minimize waste, manage the building process to reduce waste. Plan a waste management strategy. Planning is where most waste savings are created. A waste management strategy sets targets, roles, and practical site controls before construction begins. It documents how waste will be prevented where possible, and how unavoidable waste will be sorted, stored, removed, and recorded. A clear plan also aligns subcontractors and suppliers to the same waste expectations and helps demonstrate compliance if the project is reviewed or audited. Start by identifying the environmental requirements that apply to the project location. These can include government regulations, council conditions, EPA guidance, and waste facility rules. Requirements commonly cover waste classification, storage and transport, recycling targets, and controls to prevent pollution such as dust, sediment, and litter. Record the relevant requirements early so they can be built into the site waste strategy and communicated to all contractors. Building and construction methods and principles. Construction methods strongly influence the amount of waste generated. Poor set-out, inaccurate ordering, and late design changes create offcuts and surplus materials. Better methods reduce waste at the source, including accurate measurement, standardized sizes, prefabrication where suitable, and protecting materials from damage on site. Waste minimization also links to core construction principles: quality, safety, time, and cost, because waste often indicates rework, delays, and unnecessary spending. Government building and construction regulations. Building and construction regulations connect to waste management through safety, environmental protection, and quality obligations. Regulations may require correct handling of regulated waste, safe storage of materials, and controls for site impacts such as runoff and dust. Requirements also vary by project type, scale, and location, so the current rules must be confirmed for each job. In the waste plan, note what evidence must be kept, such as receipts, waste dockets, and contractor records. After identifying requirements, research environmental guidelines and standards that support better waste performance. This includes industry guidance on recycling, reuse and site controls, plus workplace and client expectations. A simple way to manage this information is a compliance or legal register that lists the requirement, where it applies, and what the project will do to meet it. This keeps responsibilities clear and makes review and updates easier as the project progresses. The National Construction Code is a key reference for building work in Australia. While the NCC is not a waste manual, it influences material choices, construction practices, and performance requirements that affect waste outcomes. It is supported by referenced Australian standards and may include state or territory variations. When planning waste minimisation, check how code compliance affects what materials can be used, how they must be installed, and what documentation is required. Environmental standards provide detailed guidance on good practice and can become mandatory when referenced by the NCC, legislation or contracts. Standards help define consistent methods for environmental management, quality assurance, and safe work. In waste planning, standards can guide how waste is classified, how materials are stored and protected, and how environmental risks are controlled. The practical outcome is a waste strategy that is consistent, defensible, and easier to implement on site. Developing a waste management strategy. A waste management strategy should be practical and site-ready. It typically includes waste types expected on the job and likely quantities, waste prevention actions, including ordering and handling controls, on-site separation and bin skip arrangements, recycling and reuse options, including approved facilities, roles, responsibilities and communication requirements, recording and reporting, dockets, receipts and tracking against targets. Waste minimisation is also a cost decision. Disposal fees, transport and handling time can be significant, especially when waste is mixed and cannot be recycled. A basic cost comparison helps justify the strategy. What landfill would cost versus what can be saved by better ordering, reuse, recycling and supplier take-back. When discussing the strategy with a client, focus on clear benefits: reduced cost, improved safety, stronger compliance, and better environmental outcomes. Waste reduction works best when it is designed in, not added later. Effective communication with architects, designers, engineers, and key consultants helps embed waste minimisation into drawings, specifications, and schedules. It also helps coordinate material selections, standard dimensions, and buildability decisions that reduce offcuts and rework. Use clear documentation and consistent channels so changes are controlled and waste targets stay aligned with design intent and site delivery. Section 3. Manage materials. Procurement to minimise waste. Procurement decisions directly affect waste volumes. The aim is to select materials that are durable, fit for purpose, and supplied in a way that reduces packaging and damage. Procurement also includes ordering accurately, planning deliveries to match the work sequence, and confirming suppliers can support recycling, take-back, or low-waste delivery options. Good procurement reduces surplus material and prevents waste created by wrong items, late deliveries, or poor storage. Choosing higher quality and more durable materials reduces waste over the building's life. Durable materials can reduce maintenance, replacement, and early refurbishment, which lowers long-term waste and cost. Evaluation should consider performance requirements, suitability for the environment, warranty and supplier support, and compatibility with other building elements. The practical goal is fewer failures and less rework during construction, and less material replacement after handover. Life cycle thinking considers impacts from extraction and manufacture through transport, installation, use, and end of life. It helps compare options beyond upfront price. A material with higher initial cost may last longer, reduce maintenance, and be easier to reuse or recycle. In procurement planning, document key life cycle factors: durability, repairability, recycled content, supplier certifications, and end-of-life pathways, so choices are evidence-based. Managing resource demand starts with accurate quantities and controlled use on site. Over-ordering and poor storage create waste, quickly through damage, weather exposure, or loss. Use consistent estimating methods, confirm measurements, and align orders to the construction program so materials arrive when needed and can be stored safely. Track usage against budget and forecasts, so variances are identified early and corrective action prevents unnecessary waste. Recycled materials can reduce waste and demand for raw resources, but they must meet performance, safety, and compliance requirements. Confirm suitability for the intended use, any standards limitations, and any testing or certification required. Examples include recycled aggregates, reclaimed timber, or recycled content products where specifications permit. The key is documenting compliance and ensuring recycled choices do not create defects or rework that would increase waste later. Waste practices can create environmental risks, such as contaminated runoff, dust, or improper storage of hazardous materials. Environmental risk management involves identifying risks, assessing likelihood and impact, and implementing controls. Controls commonly include segregation, bunding and containment, covered storage, spill response procedures, and using licensed transport and disposal providers. Clear controls support compliance and prevent incidents that cause clean-up costs, delays, and reputational damage. Recycling, reclaiming, and reuse are key to reducing landfill. Reuse keeps materials in service with minimal processing. Reclaiming recovers materials so they can be processed again, such as salvaged fixtures or recovered timber. Recycling transforms materials into new products, such as metals or crushed concrete. To make these options work, the site needs separation at source, clean storage, and clear pathways to approved facilities or reuse locations. Effective procurement reduces both cost and waste. It includes clear specifications, standardization where possible, and supplier agreements that support low-waste delivery. Procurement can also encourage prefabrication and modular components where suitable, which often reduces offcuts and packaging. Ensure ordering processes include checks for correct quantities, compatible products, and delivery timing. When procurement is planned well, fewer materials are wasted through surplus damage or incorrect supply. Packaging is a common and visible waste stream on construction sites. Procurement specifications can reduce packaging by requiring returnable pallets and reusable containers, reduced plastic wrapping, where practical, supplier take-back for packaging and offcuts, clear labelling to support recycling. Supplier selection affects waste outcomes across the supply chain. Environmentally responsible suppliers can provide products with recycled content, take-back programs, reduced packaging, and evidence of responsible manufacturing. Engagement should include clear sustainability requirements, agreed reporting, and regular review of supplier performance. Record supplier commitments and outcomes so they can be monitored and improved over time. Strong supplier relationships make waste minimization easier to maintain throughout the project. Section 4. Manage the building process to reduce waste. The final element focuses on site delivery, how waste is managed during demolition, excavation, construction, and cleanup. The goal is to turn the waste strategy into consistent on-site action. Segregation, recovery, litter controls, and safe disposal processes. Site supervision, clear responsibilities, and good logistics make the difference between a plan on paper and real waste reduction on the ground. Demolition can create large waste volumes, so the goal is to maximize recovery. Plan demolition to separate materials such as metals, concrete, masonry, timber, and fixtures. Use methods that support salvage rather than mixing waste streams. Confirm any regulated materials such as asbestos are handled by licensed specialists. Good demolition planning reduces landfill, increases recycling rates, and can create cost savings through recovery and reduced disposal. Excavation spoil and heavy materials can quickly become a major disposal cost. Strategies to reduce landfill include accurate cut and fill planning, reuse of suitable spoil on site, and identifying lawful off-site reuse options where appropriate. Prioritize reuse pathways early, so material can be handled correctly and kept clean. Where reuse is not possible, ensure correct classification and transport to approved facilities to avoid contamination and compliance issues. Litter control protects the environment, the public, and site safety. Practical litter abatement includes covered bins and secured skips, clear signage and designated disposal points, regular site housekeeping and clean-up routines, managing wind-blown materials and loose packaging. Contractor responsibilities built into contracts. Some waste is unavoidable and may be regulated or hazardous. Plan disposal by identifying the waste type, safe handling requirements, storage controls, and approved transport and disposal providers. Keep documentation such as waste dockets and receipts to demonstrate lawful disposal. Ensure procedures prevent contamination of soil and water and protect workers and the public. Safe disposal supports compliance and reduces the risk of incidents, fines, and costly remediation. Workplace procedures and safety requirements support both waste minimization and risk control. Procedures should cover segregation rules, handling of regulated materials, spill prevention, dust and runoff controls, and safe operation around waste storage areas. Safety requirements include inductions, correct PPE, and training for higher risk work. Integrating WHS and environmental controls ensures waste practices do not create new hazards and remain consistent across all contractors and stages of work. To summarize, the unit focuses on 3 outcomes. Plan a waste management strategy aligned to requirements, standards, and project needs. Manage procurement to reduce waste through durable choices, life cycle thinking, recycled options, and responsible suppliers. Manage site processes to increase recovery, control litter, and safely dispose of unavoidable waste. Thank you for following along. I trust this video has provided the guidance you need to successfully complete your assessments. I'm Sudha Udaya, and I look forward to seeing you in the next lesson.